Okay, so welcome everyone to our weekly lab meeting. I'm gonna leave the video on today just because it's won't take up too much real estate. But the question we had, Jacob had it was on 13.2.7. Now this is one of those packet tracers that is designed to do troubleshooting, which means you're not going to be able to look at the assessment items to see what you missed or didn't miss, because it is a troubleshooting assignment. They want you to walk through and look at this. So one of the things they're wanting you to do is to start out with PC1 and open up a command prompt. And one of the commands that we always use when, especially when working on PCs, is just Ipconfig. Now you'll notice that with this particular one, Ipconfig, and you'll see that there is a, it asks you to look for the mask and all those. You'll notice that the IP address for this particular machine is 10.10.198 and 10.10.197 is the default gateway. So I'm gonna look up here and see that is the correct default gateway. Our mask is 255.255.255.224, which is correct. All right. And let's now look at, actually what I would do if I was sitting here, I would go ahead and try to ping that gateway just as a test item, just to see if it, and I can reach it. So I know I can at least, at the very least right now, PC1 can reach router 1. So now then it says open PC3 and do an Ipconfig and complete the table. So they're actually asking you to just figure out what the IP addresses are on this. And this is 10.10.118, 10.10.117. Let's make sure that is the correct address on, yep, on R3, 10.10.117 is correct. And 240 is the mask. So it looks, what I would go ahead and do is ping that 10.10.17, and that is working. So we have connectivity there. Now, I can then try to ping, so it's 10.10.117 is this, excuse me, 10.10.118 is PC3's address. So let's ping from PCA 10.10.118. Okay, and it's unreachable. Now I'm also going to try 10.10.117 just because I know it should be unreachable also. Okay. Now we get destination host unreachable. So what we want to do is figure out where in the path the problem is. Is the problem at R1, R2, or R3? So what we could do is on PCA, we just type trace route. I got to get in here. Trace route 10.10.1.18. Trace RT, it's trace route on Cisco devices, trace RT on Windows boxes. And we will see that, where did it get to? On our end, from, and they're actually asking PC1, enter the commands to trace route to PC3. What was the last successful IPv4 address reached? The last successful one was our gateway. So right there. So that's telling me, let's try on the other side now. IP address 198. And that's why they have you write it down in the chart, so you don't have to try to keep remembering it. Trace RT 10.10.1.98. So we get our default gateway of 10.10.117. We get 10.10.117, and then it looks like maybe we'll get a little bit further from this side. Nope. So we're only getting to our default gateways. So that gives me an indication of we got something definitely wrong. So we're going to go into R1 and log in, and that's what they want you to do right here. Go to R1 and log in. Let's do a show password Cisco in class. Typically, if you don't know the username and password, or it tells right here, but the user exec password Cisco almost always, and the enable secret is class. Let's do a show IP interface brief. This, by the way, is one of my favorite commands and one of the ones I use the most often. So we'll see that 10.10.197 is up. We're good there. 10.10.16, the serial is up. So far it looks good. Okay. So let's do a show IP route. All right, now here I'm starting to see where we got a problem. All right, so we can see on R1 that R1 only knows about the directly connected networks. In other words, it only knows about the networks on 10.10.197, 10.10.16. So those two networks that are directly connected. It does not have any idea what the next hop is or the address should be for getting over to this other side over here. Okay. So we're inside of this router and we don't really know how to fix it. Now, Dr. Or Jacob, what was your proposal to fix this problem?
Well, they have, if you go back, I was following it step by step. In the first step, they ask you to configure they don't give you the instruction of, they say configure the switch. There's instruction there that has you to configure the switch. Yes. So, and from there, I try to configure that R1. And
Okay.
First of all, and that is where I find out that I cannot, because I was trying to find out exactly why the R1 cannot, what's wrong with it.
Right. Right now, from looking at this, I can tell you the reason you're not able to get there is because the router does not have a destination. It does not have a route to the destination network that PC3 is on. Now I'm going to go over here and just do a couple quick looks at R3. So yeah, see they're running there. This is running. It looks like it's running EIGRP. IP route. Let's see if this one's got any routes. No, that one doesn't have any routes either. So let's go here. I'm gonna look at this and see Cisco. Okay, yep, we got a route here with EIGRP. So what I would say is this, all right, you obviously don't know how to do EIGRP at this point in the class. But if I was to, when you're looking at this, what is the error? The error is that router 1 does not have a route or a way to get to the network that PC3 is on. What solution would you propose? Well, the solution would be place a route on R1, which allows it to get to the network off of R3. We're going to kind of cheat a little bit because what I'm going to do is I'm just going to do a default route. Okay, so what I'm going to do is a default route that has all traffic that's not local go over to R2 and see if that doesn't fix our problem. So I'm going to go in here and go config T. And by the way, this is very hard for you to know how to do at this point. So it would require some research on your point to be able to put in the default routes. It's mentioned, but it's not something that we've really done as part of the class yet. But as long as you realize the problem was with the routing table. Okay, so now let's see if from PC1 we can actually ping 17. Okay, not yet. Okay, let's do a Control C. Let's do a trace route. Okay, so we're going to our 97, which is correct. All right, let's go. Got an idea here. The other thing we can do is this, since they're running EIGRP, we could enable EIGRP, but we should not have to do that. We should be able to do. They're running EIGRP too. So we could have done EIGRP, but hold on one second. 10.10.1.16/28. Okay, so he does have, so from right here, ping 10, 10, 1.18. Okay, so I can ping PC3 from R2. So let's go to R1 and let's do the same thing. Do ping 10, 10, 1.18. Okay, so that is failing. So let me do this. Control do show IP route. Now I got that static route going there. So let's do a no. Oh, I can hit the up arrow a couple times, hit Control A. Since that didn't work, we try something that doesn't work, you remove it. So let's do a next hop, which should be 4.5. Let me see this. Instead of doing the outgoing interface, it should be 1615. Okay. Whoa, wait just a second. I might. No, that's it. Okay. So IP route 0.0.0.0.0.0.0 10.1.10.10.1.5. Okay. Now let's do a do. Okay. Now that's definitely interesting. So let's do this now. I'm gonna do a trace route from here. See? Should go there. Now it should go over to 10.10.1.5. We have got a loop somewhere or something.
Do 10.10 dash 1.5.
Okay, 1219 is here. Show IP brief. Oh, excuse me. Show IP protocol. Oh, I know what it is. I'm a doofus. All right. I broke the golden rule, folks. This is, golly, I can't believe I did that. All right. Routers make routing decisions based on their routing table alone. Okay. So right now I fixed the route from R1 going over to the network over to PC3. So in other words, I've got a route now from here, from R1 to here. However, I do not have a route from R3. So if I go to R3 and do a show IP route, notice there's no route sending me back over here. So in other words, what's happening, what's this? This is one of the cool things about Packet Tracer. If I do this, if I take and create a packet and go, I want it to go from here to here. All right, if I go to simulation mode instead of, I go, I want a packet to go from here to here. And I move that packet, you can watch it go. And what you're gonna see, watch this, it's actually gonna go across to R2, it's gonna go to R3, and it's even gonna get forward up to PC3. But watch what happens when it comes back. It's gonna come back to R3. Here's the ICMP echo reply, and watch it get dropped right there. So in other words, I fixed 1/2 of the problem. I created a route on R1 that allowed the traffic to get to PC3, but notice how it's failing. It can't get back. So I'm going to change something. I'm going to go back to first real time. Instead of doing a default route, I'm going to do something that you don't know how to do at this point. I am going to actually enable EIGRP. All right. So I'm going to just go in here and I'm going to go router EIGRP 1, which is an autonomous system number. I'm going to do network 10.10.1.4 255.255.252. And I'm going to do network. I'm going to advertise my directly connected networks. 10.1.96. And I'm going to do 255.255.255.224. Okay. Now, watch what's going to happen now. I'm going to do a do show IP route. And actually, I got to get rid of that default route there. Config T, no IP route. Oops. So let's do a do show IP pro. Yeah, JRP1, and I'm advertising those two networks. So let me pull, I got to pull this over here so I can see. So I got 10.10.14/30, and I'm advertising 10.10.196/27. I would also need to enable, I forgot to do, yeah, JRP1. I forgot to do the network. Oh, they don't have one down there. Okay, they don't have it on the IPv6. All right. So let's go to R2 and let's make sure EIGRP is on. And the EIGRP is on for the 10.10.14 network, 10.10.1.8. All right. So show IP EIGRP neighbors. All right, we only got it to S001. I don't know if they've changed the hold timer on this thing or not. That should have worked right there. Try to figure out. It is the IGRP1, correct? Yep, so that is right. Hold time is 240. Hold time is 240. Okay, automatic summarization is disabled. It's disabled there too, so it's that version. Oops. So we look here, we should see. Got that, show IP pro. We should be advertising our 10.10.1.8. Oh, they're just doing all the 10 networks. That works too. That's another way to do it, but that ensures that that gets it. But let's change that though. Let's do a. I'll show you what I'm gonna show you what they've done. They're advertising inside of EIGRP. They're advertising just that whole network. I'm gonna change that. I'm gonna do config T router EIGRP1 no network. All right, network 10.10.1.16 255.255 oops 255.255.255 /28 would be what, folks? 240? Is that not correct?
240, yeah.
Okay. Oh, I got too many 255s. So it'll be a 240. So that's going to advertise that network. And then I'm going to do network 10.10.1.8, 8, not 5, 8, 255.255.255.252. Okay. Now do show IP route. Now this should be (10.10.1.4/30). That should definitely be working. Now I should have a neighbor relationship between R1 and R2. Let me see. One 6/30, 4, 5, and 6. So that is correct. We'll try some ping. Okay, there's our issue. We have a problem between connectivity between R1 and R2 right here. Okay. And there it is. There's the problem. Can anybody see it?
Serial,
So serial 000 is supposed to be connected to R1.
yes.
Okay. So we've actually got it. In fact, you know what? It may not have had the problem with routing, but either way, but we do know this is the problem. This is 10.10.1.2. That's not on this network. It's supposed to be, if we look at our documentation, it's supposed to be 10.10.1.5/30. So let's go to R2 and fix the serial interface. So int S0, 0, 0, 0. Now you don't have to remove the IP address if it's IPv4, because you can only typically have one IPv4 address on the interface. If this is IPv6, you actually have to remove the address and then put the new one on there. Otherwise, you'll have multiple addresses on the interface. So I can put IP add. This is supposed to be 10.10.1.5, 255, 255, 255.252. All right, notice we got a new adjacency now. Do show IP route. I've got my EIGRP route for the 96 network. I go to R1. I do a show IP route. I now have routes that go all the way through. And I'm about to guarantee you that I can now go all the way over. Trace route's slow, so it takes a little while, but it works. See if it doesn't work. Should work. Should now be going to 10.10.1.5. Nope, it's timing out. Every single time I get in class, folks, it's like the phone starts ringing for some reason. Still destination host unreachable. Hmm. 10.10.1.18. All right, well, let's back up. Here's what I'm gonna do then. Here's how I troubleshoot something like this. We know we fixed that issue right there. So we're now going to ping. I'm gonna ping as close as I can to me. So I know that this should be 10.10.1.6, which is right here. So that works. Now we're gonna go 1.5. That works. So I'm right there on R2. Now we'll go 10.10.1.9. That works. We'll do 1.10. That works. So I'm getting all the way to here. Now let's do, that should be 17 now. So 17. So for whatever reason, we're not getting back to R3. Okay, so we should be able to now. We got that route, so let's ping 10.10.1.5. Yeah, I must have messed something up on the network there. Hold on one second. Let me see something. Yep, I messed it up. I'm not getting that network right there. I'm not getting the 116 network. So let's go look here and do a show IP prot. I must have messed up. Yep, sure did. Look at what I did. I put in the wrong network. See that? So if I go in here now and show you, you can see I put in the 10.10 network instead of the 116. So let's do this. Config. Now this is somewhere where, and you'll learn this as we move further down the road. You do have to actually remove this network command. Otherwise, you'll have it wouldn't hurt anything, but it's not good form to leave in a bad network command. And it could end up you accidentally advertising networks you don't control. So you want to try to avoid that as much as possible. 240, not 40. Now, if I put the right address in, 10.10.1.18, and it works. So we had really two issues. The main issue was that the IP address right here was wrong on R2. And then we had some routing issues that we needed to take care of. Notice how that was a little tricky because the interfaces were up. So the interfaces were up. It was just that it would not ping it because we had the wrong IP addresses. Questions about that? Pretty good little troubleshooting there, folks. Now watch this. We go to simulation now. We can click and say, I want it to go from PC1 to PC3. And now you'll see it go, and you'll watch it come all the way across. It'll go to R2, go to R3, go up to PC3. And then it's going to leave PC3 and come back. And now watch what happens. Watch it come all the way back now. See how it's coming back. So that's one of the neat things that's available inside of Packet Tracer is the ability to do this simulation. And look at that. Does that help, Jacob, with the?
Yes, it does help. I was trying to go through the 13.4 troubleshooting the way, because at the end of that, if you go to the end of it, it said document step 6. Document the solution there. So I'll just go through what you go through troubleshooting the system. So.
Right, and that's what they want you to do when it says document solution. What I would have put there is, no, up here, documented solution in the first part is change the IP address on R2 to match the table and the correct IP address, and established routing for the devices. And same thing with IPv6. I'm sure that with these, it's probably something very similar. Ipconfig, what are they? I think they're using some simulated command that doesn't really work in the real world. Ipconfig, IPv6 config /all, which doesn't exist in the real world. IPv6. /all, and shows you just there. You'll notice how it's not getting an IP address at all. And you can look at the table here where you need to have, you know, there's actually, you've got a link local address, but you've got no address, no global address on this PC1. And so more than likely the issue is if you look in here and do a show IPv6 brief, I would look here and compare that to the documentation to see if I've got the correct IP addresses on. Gig 00 should be 2001 DB8:11. Yep. S001 is FE80::1. 2001 DB8:2. Yep. :2::2. Probably what's going on with this is if you'll do a show IPv6 interface G00. It's part of multicast group, so that makes me wonder. I think you've got, yep, IPv6 unicast routing is already on. So let's go look at R2. Again, same command, show IPv6 at brief. Devices here. Oops. R2 should have on S001, S00, DB81:2::1. Yep, that's that. And then 3:::1, which is correct there. FE80::2. That is correct. Let me go back in here and check. Oh, I'm looking at the wrong client. I'm a doofus. Sorry, y'all. I'm supposed to look at this client. IPv6 config. There it is. There it's showing you 2001 DB8 :1::2. In fact, I should be able to ping 2001 DB8 :1:1 1:1:1. Yeah, that works. So then I would just go through, continue steps and going through and see how far I can ping across, and then ping trace RT 201 : I just got to find the app. Let me pull this over here. I got to find the PC4s. So it is 2001 DB8 :1:4:2. And then you'll see it's just going through the same process, and then I would just do the same thing. I would go through and find out where it stops at, and then try to determine where the issue is. So we can see it's going to my first hop. And it looks like it's going to stop there and fail as it gets to R2. So again, the problem seems to be somewhere on R2 or R3. So we could just continue to look at those and see what's wrong with those. But that's the whole idea behind this particular lab. Other questions on it?
Can you ping from 2 to 4? PC 2 to 4.
2 to 4. That's what I will try to ping right here. Yep, let me do this. So this is 4. So let's ping 2001 :DB8 :A : oh, wait a minute. You know what? I don't think it's A. Wait one second. That's a DB8. Okay, here's 2. DB8 :1:4:2. Okay, so that is failing. And the reason the other one failed is because I put the wrong address in. So let's do this. Let's Control C, and let's put this to the correct address, which should be a 1. Okay, so I'm getting over to 1.3. Right there. Okay, so that's telling me that I'm seem to be getting at least to right here. Let's see if I'm getting all the way over to 3. So PC2 is here. Pull up our documents. Okay, R3 is DB8. Yep, so I'm actually getting all the way over to R3, but it's not coming back. That's what it looks like. So we're getting there. So let's go over here to R3. All right. And let's look and see if maybe we just don't have an IP addressing problem. Gigabit 00 should be 2008 DB8 :1:4:1. This should be 2001. Okay, so that's working. So let's try this. Ping 2001 :DB8 :1:1:1. So I can get all the way from R1 or from R3 to R1 to the actual gigabit interface there. So let's ping here. ping the other side of R2, colon 3, colon 1. All right, that works all day long. So I can get all the way over there. On R3, I can ping 2001, colon DB8, colon 1, colon 3, colon 2. Okay, that works. This is from PC2, so I'm gonna ping now 2001, whoops, colon DB8, colon 1, colon 4, colon 1. All right, so I can actually ping all the way from PC2 to the interface right here on R3. So that tells me it's probably something with this client. And you'll notice, look at that. 1, 2. Let me go in here and see if that's not the issue. There's the issue. Look at the default gateway that's been set on PC4.
Yes.
It's the wrong default gateway. It should be FE80 colon 3. So let's go fix that and everything will work. And so we close this. And I guarantee you, I don't guarantee you, but I'm fairly certain now that we will be able to ping from here to the IP address of 4, PC4, which should be 4.2. There we go. So by using my pings, I pinged all the way across. So I checked my way all the way across, and I knew I could get to the 4.1, 2001 DB8 one. That almost guarantees to me the problem has to be on the other PC. So when you go down here and it says document the solution was to change the default gateway on PC4 to FF80 colon 3, which is the correct default gateway. Okay, does that make sense?
Yes.
All right. But you'll notice the process I use there, and that's how I really test things. You can use traceroute, can use ping, but if you can ping start your way along the hops. Like I said, what I do is I'll start right here and I'll ping the first default gateway. Does it work? Okay, good. Then I'll ping the next. Does it work? Good. Then I'll ping the next, then the next. And that tells me where along the path I need to do my troubleshooting. Excellent. Any other questions?
One thing with it is that because you are experienced with it, I was trying to follow the step-by-step that they have for us in the assignment,
Right.
Which it helped me to, because of your experience, that's the way that you can quickly export it. But for none that doesn't have much of experience of that,
right.
Yes, I go because I use the steps in order to go through it to see where did I mess up. Because you can identify that, okay, this is where the area is, but I have to go through the step by step
Right.
to see where I don't get what I'm supposed to get.
And that there's nothing wrong with going through step by step. And using traceroute would have worked too, because you would have seen it fails right here at R3. So that tells you where the problem is. And then we go investigate right here. Eventually, probably if you were following their steps, what you would have ended up doing is looking at the PC4 and trying to ping from PC4 to its default gateway, which would have failed. And then you would have went, whoa, wait a minute, that default gateway is wrong. It's not FE80 colon 2, it's FE80 colon 3, which is that link local address right there. So it does come with experience. It really does. It just comes with experience and working with these things a bunch and doing a great deal with.
Yeah, to work problems.
Yeah, it does take a while.
Practice.
Takes years and years. One thing I want to do real quickly, folks, is I do want to jump over to this lab 1292. I want to talk a little bit about, I'm going to do a couple things. First, I'm gonna start off with just a quick configuration on the router. So we're gonna do a basic configuration on the router. So we know we go in here and we do a host name of R1, and I'm making all this up. I'm just doing my own names. Enable secret, we'll use class. So that sets our privilege password. Banner, MOTD, do not enter. Oops. And remember that that's just our delineating character right there. I'm gonna do a service password encryption. Password encryption. I'm going to do then line con 0 login synchronous because it just saves you from having stuff spread all over your command console. Password is Cisco. Login line BTY BTY 04. Up arrow twice. Password Cisco. Login. And honestly, at this point, I haven't done the interfaces. But I just completed a basic configuration on a router in what, 30 seconds. All right. So now if I exit here completely out of this router, you'll notice there's my do not enter. I get prompted for my password of Cisco, and I've got a password of class for my enable secret. You too will get to the point to where you can do it that quickly. 30 seconds, you're done. All right. Now, I'm going to do the same thing on the switch, but this lab, I do want you to see, this lab is a lab that is only IPv6. Every single device is IPv6. Our switches, S1, okay, so let me do the base config on it real quick. Same thing, so config T, hostname S1, enable secret class, banner MOTD, stay out. Okay. Now, obviously, we use better banners in the real world. Sad thing is, I actually used to be faster before I got hit by a truck. Now I make too many typing errors. The only difference here is you got a VTY line 0 to 15 on a switch instead of 0 to 4. We're still going to do password Cisco and login. All right. Do right. Done. All right. Switches, however, especially our 2960 switches, they support IPv6, but it is not turned on by default. This, by the way, this lab, the way this lab looks right here should look very familiar to you because it's the same setup you've seen that could possibly be your hands-on. So that's why I'm showing you this, is because if in the hands-on it asks you to support IPv6 on the switches, there's a special thing here called an SDM. If I do a show SDM prefer, okay, you will notice that the default is this. The current template is default. That does not support IPv6. You have to turn on the SDM. So you have to do SDM prefer IP dual IPv4 IPv6 default. All right, and then once it does that, you have to do a copy run start. So I'm gonna drop out here. I'm gonna do it like you would do it. Copy run start, and then you must reload the device before it will load the support for IPv6. And I'll show you what happens once it reloads here in just a second. So this entire section here about turning on the correct template, the database manager template that supports IPv4 and v6, you must do that in order for the switch to let you put IPv6 addresses on the switches. Okay. Now on the router, we're going to do something a little different here. On the router, we're going to go ahead and put in our IPv6 addresses. So let's go int gi 0 0 0 1. All right. IP add, IPv6 address add 201 colon db8 colon acad colon and 001 is 1 colon colon 1 /64. And I'm going to set my link local to IPv6 add fe80 colon colon 1 link local. Hit the up arrow 3 times to go to gig 000. Hit the up arrow twice to get to this. We'll make this A. So it's subnet A. Use the same link local address. Okay. Do a no shut command here. And we need to do the same thing on G01. We need to do a no shut. I forgot to do a no shut on G01. All right. Now, the only thing I haven't done right now, if I do, let's type exit here, exit again. If I do a show IPv6 interface, G0. Oh, yep, sure did. Show IPv6 interface, G001. All right, you will see that I've got my global IP address on here. I've got my link local address on here, but I am actually not supporting yet the ability to hand out IP addresses using stateless address auto configuration. So let's go in here and do IPv6 Unicast routing. Okay, Control Z, issue the command again. Notice how now I've joined these other multicast groups, which allow me to do Slack. I should now on PCA be able to go in here. Okay, it says, do you want to work on this network? Yes, I do. I should actually be able to go in here and let me show you a quick trick. If you have trouble reading this, make it actual size and it's not blurry. So that little drop down right there, just do actual size and it won't be blurry for you. The Ipconfig, and watch what I've got now. I've got a 2001 DBA ACAD 1 address. So using auto configuration, as soon as I did IPv6 unicast routing and I put an IPv6 address on gig 001, PCA got an automatic IP address right here. Pretty neat, isn't it? It also got the default gateway, which is FE80::1, which is one of the reasons we set that. Let's go over to PCB and look at the same thing. PCB should have an IP address in the A network. So again, you can't read that. So let's go actual size, Ipconfig. And now you'll see that 2001 DBA ACAD A, and then you'll notice it randomly generated itself an interface ID. So using stateless address auto configuration, we were able to get PCB and PCA a globally routable IP address that easily. Neat, isn't it? I think it's pretty cool. Okay. Now switches up. So let's do here. Now we can do a show SDM prefer. And you'll see now it supports IPv6, IPv4. So now we can actually go in here and remember on a switch, the only difference between a switch and a router is we have to use switch virtual interfaces. In this case, we're using VLAN 1. And so I do IPv6 address of 2:0:1:ACAD:1:B/64. And then you can set your IPv6 add. If you want to do the link local, I don't think they have you set the link local on the switch, but I'm going to do it anyway, just so I know that it's 2. Okay. So now if I do a Control Z, I do a show IPv6 in brief. You should see that we have this address here, and I should be able to ping FE80::1. Oh, output interface. All right, so ping that output interface VLAN 1. And there it was, worked perfectly. I'm able to ping it. All right. We also can put static IP addresses on the PCs if we want to do so. And I need to make this full screen so I can actually get down here. So we can actually do static IP addresses here if we want to. Once I get that up, I can go back to partial screen. Oh, cancel that. I'm gonna go to Ethernet. So when it asks you to do a static IP address on the real PC, you just go into the local area connection just like you would for IPv4, but just double click on IPv6 and put in the IP address they want, which in this case is 2001:DB8:ACAD:1:3. You'll notice you put the prefix length down here. Now for the default gateway, you could put the link local address, or you can put the global address. I'm going to do the link local just because it's simpler for me. So I'm going to go do that on this side. So now if we do an Ipconfig, we should see that we are now 2001 DB8 ACAD 1::3. I'm actually going to ping 2001 DB8 ACAD 1::1, which is my default gate, or the gig 001. And I'm going to ping 2, which should be switch virtual interface. Actually, that's the wrong address. Sorry, it should be 3, which is what I put on the switch. And that's working. So let's go over to PCB. And I'm going to put a static IP address on PCB. Now, this is a very unusual network because probably very few of any of you have ever worked on a network that is all IPv6. But this network is, once you're finished with it, the only thing running on it is IPv6. There's no IPv4 running on it at all. So A, by the way, what is A? What subnet is A?
Or no, 10. Sorry.
10, exactly. There you go. 10, subnet 10. So subnet 10, B would do 11, 12, all the way up to F, and then you would just roll over and do 00, 01, 10, 20, 30, 40, 50, so on and so forth. Yeah, very, very good. Excellent. So now what we have built using, and literally in just a few minutes, what, less than 30 minutes, we built a fully functional IPv6 network. DB8 ACAD let's go to PCA 1::3. Goes all the way over. All right. Now let me see, what did I put on switch B here? Make sure. Oop. I did put B, so it needs to be B there. Okay, so let's do. Oh, you know what? Watch this. This is going to fail. Huh, it worked. Oh, I know why. Because it's got the link local already. That's why the default gateway was set. Typically, it wouldn't work because of the link local. You don't have the default gateway set, but because it's IPv6, it's got that FE80::1 in there. So it's able to actually get to the router itself. So I can ping from PCB to PCA, which is that. All right, 1.3. I can ping to the switch, which is PCB, or which is B, 1::B. And I can ping from PCB to the router interface on R1, which is 1. So we built a very simple routed IPv6 network. This is what people mostly mess up. They forget to put this in. And if you don't put that in, then the router will not respond to those ICMP v6 router solicitations. They will not send out router advertisements. So without this command, it will not work, especially with Slack. Now you could still statically assign IP addresses, and it would possibly, well, actually it won't work anyway, because then it won't route across the interfaces. But definitely Slack will not work. Are there questions about IPv6? Because if you can do this, you really can do pretty much what we need to do for our hands-on final and what we need to do.
Quick question, I guess. So each network on the router interface will have its own default gateway.
Okay, the correct answer, or the way to really look at that, is this: each interface on a router is a default gateway for other hosts. The router is the default gateway.
Right. So, but it would need to be different for each of those connected segments.
Correct. Yes. Yes. The global address is just like IPv4 addresses. Each address on these interfaces must be on a different network. Correct. So you couldn't put A::1 on gig 001 and A::1 ::2 on gig 002 because they're on the same network. And so it'd be the same as putting two IPv4 networks on, trying to put them on, it would say overlaps. Let's try that. Let's try putting it on there. Let's go back to R1. Okay. So right now, let's do a show IPv6 int brief. And I always do that. And you'll see that we're on two different networks. We're on the A network, and we're on the 1 network. Now, something really weird about IPv6 too is this. What's this? We typically can only have one IP address on an interface, right? Well, if I go to int G00, 0, 0, there we go. I'm gonna do IPv6 address, and I'm gonna put 2001:db8:ACAD:, and now you'll see gig 001 is network subnet 1. So I'm gonna try to put 1::2 here and /64. It should tell me it overlaps. So you're seeing you cannot put the same network on both sides because they overlap with one another. So right now in this particular network that we have built, we have the following networks. We got 2000, or really subnets, 2001 db8:ACAD:, A:/64. We also have the network 2001:db8:1:/64. Okay, so those two networks, this one and this one. And if I do this, I'm gonna break my rules. I'm gonna do show run. I don't like using do show runs as troubleshooting commands, but I'm gonna show you how this is so you can see it clearly. You can see right here, we are on the A network and we're on the 1 network. So that's why I can't put gig 000, I can't put its interface in the 1 network. Now here's something, let me ask you this. Is this network is that different than every other network that we've got right now, that we've got in our environment right now? Is that a different subnet? Yes, the answer is yes. This is subnet 1, this is subnet 10, this is subnet 11. Now let me ask you this question. Can I put this IP address? Can I put that IP address on gig 000? Let's take a vote. Everybody vote. Jacob, what's your vote? Yes or no? Jacob, you voted yes, I think.
Yes.
Okay, Tracy?
Yes.
Okay. Francisco, what's your vote?
Yes.
Okay, and Jelani?
I'm gonna say no, just
Okay.
to be contrary.
All right, that's
Yeah,
fine.
I would say no. Yeah,
All right, well, let's do this then.
because it's B and A.
000 IPv6 add 01:db8:B:1/64. Works no problem. Now here's something that confuses people. I'll show you something even wilder. Okay, so now you'll see on gig 001, there's 2 globally routable IP addresses on here. Well, guess what? The next one is 2001:db8:C:1/64. One of the unique differences between IPv6 and IPv4 is I can keep putting addresses on here.
I ran into that yesterday.
Yep. And the problem is that's why if you accidentally put the wrong address in and then forget to remove it, you can end up with something like this. So I've got A, B, C, D, E. I can do F, then I can do 10, then I can do 20, 30, 40, 40. I can put as many really as I want on there. Now, How practical is that? Not very, but it does get people in trouble because if you put the wrong IP address on an interface, you've got to remember to take it off. Okay, and the easiest way to do that is
Do
go back.
a no IPv6 address.
Let's
it
try it
removes
because
all of it,
I don't know. Let's try it. No IPv. I think so. V6 add. I think do show run. I think that'll get rid of all of them. Yep, sure does. Okay, so you can get rid of all of them and then go back and fix it. So you can do that, and then you got to just do an IPv6 add 201:DB8:ACAD::A::. By the way, you know what ACAD stands for? Cisco Academy, ACAD. You know, you wouldn't know how long it took me to realize that, but ACAD
if you have two IP addresses on an IPv6 interface, are they both accessible? Or can you ping them both? Or
if you know, that's a really good question. Let's try something. I want to try this. Let's try let's put, okay, which one is on? It's a gig 000. Okay, that's that one. So let's try. Okay, so we got A, B. Let's do C. All right, and that is on. Do show IPv6 and then brief. Okay, so that is on gig 000, which would be over on PCB. Let's see if PCB pulls itself two IP addresses. Let's do a release. Let's do a renew. Oh, I might IP. Is that an actual command? Nope, I didn't think it was. All right, let me try. There's more than one way to skin a cat. Let's do this. Let's pull up our network settings. We got to go change it back to being DHCP. So let's go back to DHCP. Forgot I'd set it static. So let's make it DHCP and see what it pulls. Because what I'm interested in knowing is if it's got two global IP addresses, will the client pull itself an IP address in both networks? Which it may. Okay, I'm gonna shut the interface. Let me shut the interface down and bring it back up. That's an excellent question. I have never actually thought about it. Sure enough, look at that. Cool. That's neat. That's good to know. So now you could ping, you could actually be, well, you got an IP address on both networks. Hey, think about this. Where could this be useful?
If you had multiple interfaces on a device,
Multiple interfaces
or
on
no,
a device?
that would be the same.
Well, that's still possible if you had multiple interfaces on a device and you wanted them to be part of multiple networks. I'm thinking, what if you had to renumber your network and you wanted to have both networks running at the same time? If you're doing IPv6, you could have the A and the C subnets running both at the same time, get everything up and going, make sure it's working, then you could depreciate the A network. So that's neat. That's excellent. Hey, I love learning stuff too, so that's really good. Let's do this. Let's get rid of, let's do a control A, do a no here. All right, and go back to PCB and do an Ipconfig/release. An Ipconfig/renew, and now it should only get a C. It should only get an ACAD::C. I may, yep, it's identifying as trying. Give it a few seconds here. Oh, I forgot to put the, I forgot to do FE80::1 on gig 000. That's all right. All right, let's disable this thing. Try again. Ah! Welcome to the real world. That's funny. Okay. We don't know. I'm pretty sure it would just drop the one and get the other. So real world problem. I'll try it over here. Let's see what we got. We got do show IPv6. So we got one here. So let's do int G0, 0, 1. Man, that key aggravates me to death. Let's do IPv6 add 201 colon DB8 colon ACAD colon. I'll try F0 colon 1 / 624. Okay. PCA, if I set it to be dynamic, so we'll go back in here because we'd set it static, but we'll go to dynamic. Back over here. Now we'll do an IP. I don't want to do it either without it being. Say, well, watch me crash this one too. It'd be funny. It wouldn't be funny, but it would be funny. This one rebooted at least so we can see what it got on the second try, but it should just get. Okay, so we got a 1 and an F0, so that did work. So we go back to R1 and we get rid of the 1. Okay, PCA. Watch me crash it again. Let's see if that one will actually renew it. Now let's see what we get here. And we'll call it quits in just a second, folks. I just thought this was an interesting little thing to try. Okay, it grabbed just C there, which is good. That's interesting on that. So it did just pull C once it finally rebooted. Let's see what PCA is going to do here, if it will ever do its thing. I want to see if I can replicate. I'm going to try to replicate the blue screen. I didn't die. That's interesting. Yep, got F0. So it will pull once you release renew and finally get it going again, it will pull just that one. So that's neat. That was a good test. I like that. That's cool to know that it will actually pull an IP address from every one of the global routing prefixes that you put on the interface. Really neat. Excellent. All right. Any other questions on IPv6, how putting it on interfaces? Just don't forget that IPv6 unicast routing. That's an extremely important item that you've got to have in there, because without that, it's not going to route, not going to turn on Slack. The other item, anytime you're dealing with the 2960 switches, make sure it's got the dual IPv4, IPv6 SDM switch database manager loaded. Otherwise, it will not allow you to put an IPv6 address on the 2960. All right. Any other questions, everybody? That's all I've got for today. I know we run a little long. I apologize, but I thought it was a neat little thing to do. Thank you, everyone, for being here. I really appreciate it. I hope these are being useful. Next Thursday, if you will, actually, I believe, let me check my schedule. I think I'm actually on PTO next Thursday. I've got two, next Thursday, no, take that back. It's the week after. No, I'm here next week. So next Thursday, bring any labs that you have questions or problems with, or email them to me and I can look at them again. I'm not taking time off until the next week. I've got a couple, I don't know if we get personal days, and if we don't use them by the end of the year, we lose them. So I've got 2 of those left, and I don't want to give them back to the state.